Number 41. So bridging the gap between the detector center, which is positive, electrode and ground electrode. So bridging the gap between the detector, which is center, positive electrode, and the ground electrode. So possible failure related ferrous metal particles in turbine engine oils cause an electrical indicating type magnetic chip detector to indicate their presence by bridging the gap between the detector, which is the center electrode, and the ground electrode. So how are magnetic chip detectors used to indicate that there's something there? Because those particles will bridge the gap between the detector center and the ground electrodes. Fair enough? Possible failure relating ferrous metal particles in turbine engines oil. So the little tiny ferrous metal particles, when you pull out a chip detector, you're looking to see if there's anything in there, right? Well, sometimes you're gonna see little fuzz. Those are little ferrous metal particles. And what happens is that they actually cause an electrical indicating type magnetic chip detector to indicate their presence by bridging the gap between the detector center, which is positive electrode, and the grounding electrode. All right? Bridging the gap between the detector center and the grounding electrode. All right. Number 42, insufficient lubrication. Insufficient lubrication. So what would be the probable result of the oil system pressure relief valve should stick in the open position on a turbine engine? Well, you're going to have insufficient lubrication. So the probable result of the oil system pressure relief valve, if it's stuck in the open position, you're going to have insufficient lubrication. If the system pressure relief valve is stuck open, you're going to have insufficient lubrication. All right. Number 43, cool the oil. Cool the oil. What is the primary purpose of the oil to fuel heat exchanger? Oil to fuel heat exchanger. Cool the oil. Cool the oil. So what happens to the other side? It heats up the fuel and it cools the oil, right? So the fuel cools the oil and the oil heats the fuel. That's what the heat exchanger is all about. Cools the oil. Number 44, oil pressure relief valve. Oil pressure relief valve. So what unit in an aircraft engine lubrication system is adjusted to maintain the desired system pressure? What unit in an aircraft engine lubrication system is adjusted to maintain the desired system pressure? And that would be your oil pressure relief valve. Your oil pressure relief valve. Oil pressure relief valve is adjusted to maintain desired system pressure. Number 45, should be limited to the engine manufacturer's recommendations. Should be limited to the engine manufacturer's recommendations. So low oil pressure can be detrimental to the integral engine components. Low oil pressure can be detrimental to the internal engine components. However, high oil pressure should be limited to the engine's manufacturer's recommendations. So you can't have too little and you can't have too much, right? Low oil pressure can be detrimental to the internal engine components. However, high oil pressure should also be limited to the engine's manufacturer's recommendations. Limited to the engine manufacturer's recommendations. Number 46, provides a proper oil spray pattern from the main bearing oil jets. Provides a proper oil spray pattern from the main bearing oil jets. So what is the purpose of the oil breather pressurization system that is used on turbine engines? It provides a proper oil spray pattern from the main bearing oil jets. Provides a proper oil spray pattern from the main bearing oil jets. Number 47. Provide optimum turbine blade tip clearance by controlling thermal expansions. Provide optimum turbine blade tip clearance by controlling thermal expansion. So the purpose of directing bleed air to the outer turbine case on some engines is to provide optimum turbine blade tip clearance by controlling thermal expansions. Number 48. Provide a high engine oil pressure when the oil is cold and automatically lower the oil pressure when the oil warms up. That makes a lot of sense. Provides high engine oil pressure when the oil is cold and automatically lowers the oil pressure when the oil warms up. So some larger reciprocating engines use a compensating oil pressure relief valve. Compensating oil pressure relief valve. Once again, compensating oil pressure relief valve. What does it do? It compensates the pressure of the oil when high engine oil pressure, when the oil is cold. When the oil is cold, it'll have high engine oil pressure. And then it will automatically compensate or lower the oil pressure when the oil warms up. Okay? Compensated oil pressure relief valve. Provide a high engine oil pressure when the oil is cold and automatically lowers the oil pressure when the oil warms up. Number 49. It's a relief valve. Relief valve. Relief valve. So in order to relieve excess pump pressure in the engine's internal oil system, most engines are equipped with a relief valve. Relief valve. Number 50. Pistons and cylinder walls. Pistons and cylinder walls. So what is the source of most of the heat that is absorbed by the lubricating oil in a reciprocating engine? Pistons and cylinder walls. What is the source of most of the heat that is absorbed by the lubricating oil in a reciprocating engine? Pistons and cylinder walls. Pistons and cylinder walls. Guys, take a quiz, and I'll see you soon.